All right, so today we're going to talk about Newton's first and third laws of motion. We've already talked about Newton's second law of motion, that's F equals ma, or the law of acceleration. But today we're going to talk about Newton's first law, the law of inertia, and this third law, the law of action-reaction. So, Newton's first law of motion, the law of inertia, states that, let me kind of tilt my paper so that my handwriting doesn't look bad. An object in motion will stay in motion and an object at rest will stay at rest unless acted on by an unbalanced force. So an object in motion will stay in motion, and an object at rest will stay at rest unless acted on by an unbalanced force. So basically, if a ball is sitting, or my mouse here, is sitting on the table, it's not moving. And it's going to stay not moving until it's acted on by an unbalanced force. An unbalanced force is any force that's greater than the forces that are already affecting the object. So right now, all of the forces on my mouse are balanced. Gravity is balanced, the normal force pushing back up against my force, or against my mouse from the table, is balanced, and there's no push or pull force from me. But if I apply an unbalanced force, so I bring my finger in and I start pushing my mouse, now it's an unbalanced force. And that unbalanced force allows the object to move. And the object is going to stay in motion until either the force stops being applied that moved it, and the forces become balanced again, or until an opposing force comes in and stops it from moving. Inertia, to quote Bill Nye, is a property of matter. The inertia is basically how much an object resists a change in motion. Basically, how difficult it is to start or stop the motion of an object. So how hard it is to start or stop the motion of an object. The inertia of an object depends on its mass. All objects have their own inherent inertia. We talked previously about how heavier objects require more force to move them than lighter objects do. And that has to do with their inertia. A light object, like my mouse or like my pen, are pretty easy to move. It's not hard to start or stop the motion of those objects because they're pretty light. But a heavier object, like a bowling ball or a bike or a car, heavier objects are going to be harder to stop because they have a greater mass. So I have a couple picture options in Canvas, so look in Canvas for the ideas or come up with your own. Let's look at this key idea. An 18-wheeler and a skateboard are both traveling towards you at the same speed. Which one will require more force to stop? That one should be pretty simple. The car. the 18-wheeler will require more force to stop. Why is the 18-wheeler going to require more force to stop? Well, it's a lot bigger. It's a lot heavier. And because it's a lot heavier, it has a greater mass, then it's going to have a greater inertia. See if I can spell today. Inertia. Here's a key example for Newton's first law. This is one that when we do practices where I ask you to identify the laws, where kids get confused by this one. So you're riding in a car when the person driving stomps on the brakes. You jerk forward and are caught by your seatbelt. Well, why did that happen? When you're in a car, you are traveling at the same speed as the car. When the car stops, the unbalanced force is acting on the car, not on you. So you continue to move forward until you get caught by your seatbelt. So let me kind of summarize this. So when the car is in motion, you are traveling at the same speed as the car. When the car stops, your inertia carries you forward until you are caught by your seatbelt. And that seatbelt is an unbalanced force. So it happens to me all the time where I'm driving in my car and I come to a sudden stop and something rolls out of my passenger seat onto the floor, like my purse goes everywhere and spills all over the place. Pretty common thing. Okay, flip over to the back. Newton's third law of motion, law of action and reaction. This states that for every action, there is an equal and opposite reaction. This one's pretty simple. So again, you're going to draw a picture. I have some options in Canvas. Here's an example. You have a swimmer and they push off of the wall. When they push off the wall, they're exerting a force on the wall. That's the action. The reaction is that the wall pushes back with an equal and opposite force. All right, those are, I think I should zoom in maybe. Those are Newton's first and third law of motion. Down here at the bottom, we have some keywords to help you identify when a question is asking you about the first, second, or third law of motion. So the law of inertia is where you see anything about a change in motion, if there's no change in motion, if an object is at rest, or if you see the word inertia. The second law of Newton's second law, the law of acceleration, if you see the words accelerate, mass, more or less force. And the third law is if you see something about opposite, equal force, or action and reaction.